Since the invention of electric motors, the demand for it expanded vastly. They are found in applications as diverse as industrial fans, blowers, pumps, machine tools, household appliances, disk drives, and many other applications. Motor is simply a device that transforms electrical energy to mechanical energy. For instance, take a 5 kilowatt motor. This means that it can ideally take in 5 kilowatts of electrical energy in the form of alternating current and outputs 5 kilowatts of mechanical energy. In reality, what happens is that the motor outputs less power. As an example, if we supply the motor with 5 kilowatts of electrical energy, we would get 4.5 kilowatts of mechanical energy. That is a difference of 500 watts, which corresponds to 90% efficiency. In general, the motor is never a singular unit. It never works alone. In fact, there is a device that runs the motor called motor drive. This device runs an algorithm according to the current state of the motor and the desired state of the operator. For example, if the operator desired 2000 rotations per minute and the motor was running at 1800 rotations per minute, the drive will send a signal for the motor to step up its speed till it reaches the desired 2000 rotations per minute. Once the motor attains this speed, the drive will maintain that state. Not only does the drive control the state of the motor, but it also determines the efficiency of the operation. This is a direct result of control algorithms which differ from one drive to another. These control algorithms are the main reason we could reach as high as 90% efficiency with primitive motors. With MotorMind, the aim is to adjust the driver factor to improve the efficiency of the system. That component by itself affected by the parameters of the system, which is the motor in our case. During operation, the motor runs into parameter variations due to heating issues while being used. Take the stator resistance for example. It's directly affected by temperature, which changes its value and therefore impacts the overall efficiency. As a solution to overcome this problem, the goal is to use parameter estimators in the system to achieve robustness against parameter changes.
Induction motors are known as the workhorse of industry. They are the most often used equipment for a variety of purposes. Driving pumps, driving compressors, driving fans, conveyor systems, all of it. All the motive action, you could say 90% is done by induction motors.
As you know, the induction motor is the most important in the stations what we have, as less maintenance. The most failure in the induction motor only the bearing, what we facing in our station. Sometimes there is a short circuit in the winding, and what we doing, we send it to the insurer to repair or to overhaul the motors. That's it.
From my experience, apart from the routine maintenance that goes along with the induction motor, like routine replacement of bearings and certain cleaning of the induction motor in terms of fan, the cooling ducts and things like that. More than the induction motor itself, it is the control gear and the switch gear that drives the induction motor that needs more attention. We call it, sometimes you call it contactors, we call it electronic control gear, soft starter modules, variable speed drives. It can be a host of things like that, depending upon what purpose the motor is used for. By reliability, we mean how often does this equipment break down, have some problems and things like that. And if you look at induction motor, the reliability is very, very high. Not many things that go wrong with an induction motor.
Only the control we're using, some big motor we use the soft starter motor. The other, no control, no special control for small motor.
If you need the pump to be driven at different speeds, in some cases, yes, we need it, then we introduce some other systems to control the motor. In variable speed, what we are doing is we are controlling the voltage and we are also controlling the frequency. Now, the output frequency which is given to the motor controls the speed of the motor. So, this is how it controls the speed. So, what the control guy in the control room, if he wants to rotate the pump in a certain speed, that means a certain flow, then he will control the speed based on that. So, the characteristics of the induction motor, the motor takes a very high starting current, and then the motor picks up the speed, the current will come down and then settle at the full load current or the full running current. So this is if you plot a graph, you will see a curve that goes very high, which is indicative of the starting current, and then it comes down to a certain level. So this starting current can create some challenges. Like for example, some systems may not be able to cope with the starting current. So you need to look at means and ways how you will control that.
So far, we have chosen the induction motor as our motor of choice. This is the most common type of AC motor used in the industry. The single-phase induction motor is used mainly in household appliances like fans. The three-phase induction motor is used mainly in industrial applications like compressors, pumps, etc. An example of these applications is a centrifugal pump. Centrifugal pumps are used a lot in the industry as they have very unique properties such as working on wide range of flow rates. They require use of speed variable motor drives such as MotorMind to vary the flow rates by varying the speed of the motor driving the pump. The pump requires a minimum safe flow rate, so the motors must be stable and be able to work accurately at lower speeds. What we deduced from studying the applications is the following. 1. Wide range of operation, such that the motor can drive the application at different speeds with similar speed responses. 2. Robustness against parameter changes, to be stable and accurate across its operation. 3. Fast speed responses. The motor has to adapt quickly to input speed changes. 4. And finally, low steady state error. Some applications are sensitive to the error in the driving motor, so the steady state error must be low. So far, we have chosen induction motor as our motor of choice. This is the most common type of AC motor used in industry. So far, we have chosen induction. والله حسنا بيطلع اي وقت كثير بلو. اكيد كم بليز ما بتطلع في الماء. لا تخرب لا تخرب الماء. زين؟
بدأ الفيديو اصلا.
So far, we have chosen induction motor as our motor of choice. This is the most common type of AC motor used in industry. The single-phase induction motor is used mainly in household appliances like fans. The three-phase induction motor is used mainly in industrial applications like compressors, pumps,